Hey, what are you doing?
This is my instrumentation project.
What project is it about?
It's about signal conditioning.
Oh, what is signal conditioning?
Basically, signal conditioning is a process where you prepare the output signal to be clean, stable, and usable for further processing. It's usually sent to the microcontroller for further processing.
Oh, wow. Is there anything else interesting that you want to say?
Actually, yeah, there is. In our case, the signal conditioning that we're doing will be analog to digital converter. So basically, we measure the temperature using a thermocouple. That will be our analog signal, and then it will be converted to a digital signal, which is under binary form. And yeah, then it will be read through the microcontroller, and we'll get to what the make the cooling fan on under a specific temperature.
Bro,
Yes.
what is the signal conditioning? I can't see any signal conditioning here.
The signal conditioning is actually internally integrated in the thermocouple. So first, what the thermocouple do is that it generates an analog voltage which varies with the temperature, and then it will be sent to analog digital converter that is inside the thermocouple, and what digitize the data, the analog data, and the analog digital converter has 12 bit resolution. So then the data is formatted in a 16-bit what do you call it 16-bit form, which represents the temperature in Celsius. Then the data is stored on a scratch pad, an internal RAM scratch pad, which can be read through over a one wire bus. So basically, the Arduino will read the temperature from the one wire bus. So the whole process happens inside the thermocouple. It's internal signal conditioning, but basically it's an analog to digital signal conditioning that's happening inside.
Hello everyone, I would like to share on why our system does not require an external signal conditioning. So the first reason is because our DS18B20 uses a one-wire digital output with CRC. So this means that our sensor transmits data over a one-wire digital interface, which is resistant to analog noise. So this makes external filtering unnecessary. It also includes a CRC, which is a cyclic redundancy check, and it is used to detect and correct communication error over long cables if necessary. This ensures reliable and accurate data transmission over cable, which is crucial in this situation. The second reason is because our sensor has a built-in parasite power with internal capacitor. So what this parasite power mode does is that it draws power from the data line and stores it in an internal capacitor. The capacitor powers the device during conversion, which helps in stabilizing the voltage, and it also smoothens the transient drop. This helps in minimizing any other noise related issues, and it makes any other external signal conditioning unnecessary.
Okay, hello. Today I'm going to discuss about the full implementation of the system. So I'm going to start off with the Arduino Uno. So this is the Arduino Uno, which is connected to a cable. This is the transducer, which is the thermocouple. So our signal conditioning is actually inside the transducer itself, which was explained by Yash just now. And the Arduino Uno is connected to the 5-volt power relay and integrator, where it integrates the signals from the transducer itself, and there's a power module here, which it makes the circuit independent without the need of connecting Arduino Uno to the laptop. So how this how the system is going to work is, I have coded inside the Arduino Uno where the system should be, when the thermocouple reaches 60 degrees Celsius, the fan of the DC motor here will turn on. So in this case, I set it to 33 degrees Celsius. So when I touch here,